here for it. You want to like, I can sit over here and hit the button if you want to.
Please begin your presentation. What you did the last time, same way.
Well, hello everybody.
So just one. So hello everyone. This is the course of Digital Electronics and Microcontrollers course at the University of Tennessee at Chattanooga. We have to say the Chattanooga especially. And in this course, our students are preparing some projects using the materials what they have or what the department is providing. Yes.
I don't think your phone's recording. If you were trying to record on both, your phone's not recording.
Oh.
That matters.
Are you recording with the phones also?
Yes, I think.
Yeah, your phone.
It's not on.
That's not photo though, yeah.
No, it is recorded.
The phone, though.
Phone? No, phone is taking the picture.
Oh, wow.
This is for, you see, this is the remote control. It started with the role of the remote control. You're right, it is not recorded, but I am using for taking the picture. Both of them are doing at the same time.
Take two.
Okay. So, there are projects, and we have 5 groups, and the first group is established by the people, Micheal and Cole. They prepared together, and the ideas were selected by the students. They are preparing the proposal for the project, and after evaluation of the proposal, we decide about the final project. And our aim is to use as much as we can more sensors in the project, because you know when we are discussing about the mechatronics, then sensors, everything is done automatically, and it is preferable to use more integrated circuit, etc. And now your turn, please introduce yourself first, and later share your ideas with us.
Well, my name is Cole Stevens.
My name is Micheal Liles, and our automated system was a key access RFID and touch sensor. There's a huge push in security now, and we wanted to implement a 2-factor secure access automated system.
So the summary of our presentation, first we're going to go over the overall circuit. Then we're going to go through the parts list that we use. Then we're going to show the Proteus circuit, which is a software where we can kind of design our circuit. Then we're going to go over the code. We're going to show a video of the circuit running, the difficulties and limitations of the circuit, and then we're going to conclude.
And as you know, you will take notes and ask questions. If your questions are excellent, then I will add some additional points to you. Try to create some interesting questions.
So this is a picture of our overall circuit. As you can see the touch sensor, the RFID scanner, LEDs, the speaker, and the servo motor, and of course the Arduino that's used to control everything. So the first part of our part list is the servo motor. This one can change how many degrees it turns, so we have it turning 90 degrees to show kind of like a locking mechanism. Then we have the Arduino, which is kind of the brains of our entire circuit, where we will code it and give it parameters for what we want it to do. The next part through the tangle wire is the RFID scanner. What that does is it will read a code on another chip. And if it's the right code, it'll grant access. If it's wrong, it obviously won't grant access. The next section is the LEDs and wires. It allows a visual confirmation of the circuit running, or if the code is correct or incorrect, or if it's waiting for another like input. Next part of the parts list is the speaker. This gives a audio cue for if it's correct, or needing another input, or if it's incorrect. Next part is the touch sensor. This isn't like a fingerprint scanner. This just needs to have like a finger touch to it, but it can actually touch from any side, including just the top. You can actually not even touch it. You just have to get very, very close to it, within a few millimeters, and it actually activate.
So what we did here with the Proteus mock-up version is, so we overlaid the actual images of the units, and we drew lines from terminal points to each connection, so you have a clear representation of exactly where everything hooks up on the breadboard. I just want to point out that the RFID sensor does take a 3.3 volt power source here that's located on the Arduino, just so that we don't burn out our sensor. I went ahead and added labels to the outputs just for ease of use, to give you verification of where they go, because this can be a little confusing in this area. So I thought I'd run the code by you guys, a little bit of explanation, and I'll actually go through and demonstrate as we walk through the code. So at the first right here, we're basically just initializing the Arduino, the MFRC, which is the RFID sensor, and the servo motor itself. So we're making an instant of each one of those sensors inside the program. So here we're just declaring the open and closed state of the servo and initializing it here. This section, we're declaring the integers that's going to be used. This is in place of the numbering system so that you can get a better idea as you're in the code, actually what everything actually is. Here we're just seeing what time, how many times previously the LED states have flashed on and off, so that it's not constantly flashing. And here we are initializing the RFID pins. We got the reset pins, and it should be initialized. So here we are. This is the initial setup of everything. And I'll actually go ahead and demonstrate what this looks like. This code. So right after the void setup, you'll see everything come on, and the lights flash and initialize. So what you're seeing is actually this section right here. So it comes on, and if you had a serial hooked up, a comms, you would read the text, place a card or reader here. But we didn't have enough inputs to be able to do that on my Arduino. So we're attaching the Arduino to this process, and here is where you saw the LEDs flash on, and the speaker, it's kind of hard to hear, and the speaker come out and give you a tone to let you know that it's ready. And here's the main loop of the code. So this loop right here, this is the if statement. So if the touch capacitor is low, and this is a normally closed sensor, you would expect it to be a normally open, but for whatever reason, this is a normally closed sensor. So that's why we had to do it in the low state in order to get inside this if statement. So once you touch it, it changes and it gives you that audio key that you have completed that circuit, and it lets you know visually by turning the LED on. And that's what this right here. So digital right yellow LED 1, that's a high voltage, that LED that turns it on. And it gives you the tone right here that gives that tone. Then again, if you had a terminal connected, it would say, please swap access card, because it's a two-factor. So you put your finger on it, but you still need to swipe the card. We have a count in there just so it won't keep flashing at you to the if loop. So once it gets out of that, we change the count back to 2 so that it doesn't keep flashing that light at you. So this next section in our loop is actually checking for a card being present near it. I'll show you what that looks like. So as it's running right now, it's constantly checking to see if a card is actually near it. So once you put it, it automatically reads, and you can see that it's sensing a card. And it's doing that automatically through a loop process. So it just keeps running constantly until it gets some kind of input. So that's what you're seeing here in this section. Now, if you had a terminal hooked up, you will be able to see the actual key fob access number printed on the terminal here with this little code section right here. We'll go ahead and go to the next one. And here is the section where it's actually verifying your card and correcting it, or what's the word I'm ensuring that you have the right access card that you're swiping. So it compares it to the string right here. And again, I've set it up to where the key fob is the correct and the card is the incorrect one. So you can see what happens if you swipe an incorrect card. It'll give you a lower tone, and it'll flash the red light at you. If you swipe it too many times, it'll sound an alarm. You can go into the code, maybe alert security that someone's trying to use an access card that they don't have in a place where they don't have access to, so that you can send somebody to find out what's going on. But if your key card access matches the correct string, it'll send it on into this if statement. And again, if you have a terminal, it will read authorized access. Then here it will open the servo. I'll show what that looks like. So again, you have to do the touch sensor and then scan it. And it'll actually open this servo. And after a predetermined amount of time, it'll automatically close. So that whole process is this section of code right here. So it opens, it lets you know, it gives you the tone where you've gained access, then it'll flash, then it'll come back down here and then close the servo. That's your automatic roll-off process behind you. And that can easily be changed in case you want to adjust the time. You can actually install another capacitive sensor in there where it wouldn't close until a door is locked, or some other sensor like a laser sensor. And so if you swap a card and it's not the correct one, it goes to this statement where this is if you've swapped your card too many times. If it's not the correct password, it'll lock you off and give you the alarm tone that I showed you guys earlier. Then that's actually the last code section involved here. So you can see it's a simple process of if statements inside of a giant loop. So this thing's constantly running through checking for cards and then qualifying for each section of the loop of what you actually want to do with it. Oh, sorry. Yeah, this next section is the so if you scan the correct key fob, but you do not put your finger on the sensor, then if you had a terminal, it would say, please put your finger on this capacitive sensor. And then once you do that, it'll accept it and let you into the door. Again, this is your two-factor authentication, just to make sure there's an actual person in front of the unlocking mechanism, so that it prevents cyber attacks and any kind of instances where you might have someone trying to gain access to an area where they're not physically at, or have someone gain access remotely and then let someone else inside the building. And here, this is the last little bit of code. Basically, it says if you don't have access, it's going to read to you access denied, and then you start a swipe count. So if you do swipe 4 or more times, it'll alarm, let the system know.
So I was already touched on the reasoning a whole bunch. It's mainly just for two-factor authentication. I know everybody's had to deal with duo push online, trying to get into their emails, into their school accounts and stuff like that. So this is kind of a way to represent that in an electromechanical system. A lot of times people can just go up and press a button, but this causes you to have to scan something and then touch it. We have a video of the project here. Mike's already demonstrated it live, but this is a video showing how everything works much more close up if everybody's able to see that better. So first he just scans the RFID without doing the touch sensor. Then he does it with both, and then it allows the green LED and a good sound to pop up from the speaker. It actually turned the servo. Then it'll show swiping the wrong card with the red LED flashing, and then after you do it 4 times, it'll start flashing and play an actual alarm sound.
Yeah, some of the limitations we had is definitely the size of our Arduino. We were going to go with some more sensor capabilities on it, but we've pretty much maxed out the entirety of what that small LU R3 can handle. So the other thing is just the sheer amount of wires. There's jumper cables. It's just kind of unruly at times. It can get in the way, and sometimes even trigger the capacitive sensor occasionally. And I hit on the fact that the touch sensor was a normally closed switch, acts as a normally closed switch. So we were going to use an ISIN integrated chip and gate to wire that, but because it was normally closed, it doesn't send a one signal, it doesn't send a high voltage signal, so we couldn't use the AND gate to and a 1 and a 0. It wouldn't have operated properly. So we decided to opt to go with the full Arduino capability.
So in conclusion, our project uses multitudes of sensors and other electrical components to show what two-factor authentication could look like. This is obviously for more like a locking mechanism, it's like a door. But this could also be used for different situations that just require an on-off for a start button. And there are contacts if anyone has any questions outside of class, but otherwise, do you have any questions for our project?
So first of all, thank you very much. Now we are taking your questions, and as I mentioned, interesting questions will be graded. Okay, Dr. Kat.
Yeah, good job. So, what knowledge did you use for this project that you learned from that course, from this course?
This course?
Yes.
The first lab that we had to program just any sensor to perform some automated task. Our first lab involved using an ultrasonic sensor that we programmed to judge distance, and if it was within a certain amount of distance, I believe we chose 8 centimeters, it would flash an LED. So we used the knowledge that we gained from hours of trying to make that thing work, and it's really just a matter of switching some pins and changing a little bit of code to get something like this to work. Because basically it's all just if statements in a big loop, and as long as you know what your pins do on your sensors and your chips, it's just as simple as changing a little bit of code back and forth.
Also using Proteus in this class specifically. With the way that we have this Proteus set up, obviously it won't run the simulation, but if we use something that was an Arduino, you can actually put the LEDs in with the voltage source and then actually turn the circuit on to test it before you actually build the circuit. In this case, it's just a really nice way to represent it rather than trying to look at the circuit with all the wires sticking out of it. It's a much nicer way to look at where things connect.
Yeah, it's easier to make sure your circuit works in Proteus and then bring it to real life rather than just trying to pick around and make it work on a breadboard.
Thank you.
Other question, Wilhelm?
So say y'all were using this as like a security lock on the gate or something, how hard would it be to modify it so like in the case of some kind of emergency situation like a fire or someone had a medical emergency that like emergency personnel could like bypass the lock?
Bypass it?
Without having to like just break the door?
We usually code on automatically locking doors state that if you're on the inside, they break free.
Yeah.
So usually the door design would have that covered.
Yeah.
Other than that, most locking mechanisms don't have an emergency access to them, simply because all firefighters, emergency personnel won't have a key fob.
Yeah.
So there's the only real fail-safe involved in door systems is just being able to force it open, whether it's locked or not, from the inside.
Yeah.
Other than that, emergency crews would have to get like a jaws of life or just axe their way through it.
I was thinking like would there be a way like with the code to you probably have to like wire it into the building or something, like if the fire alarm for the whole building goes off, it just...
Well, yeah, ideally what you would have to do is similarly to how it was constantly looking for the RFID card, you would add maybe an if statement there. If this state, an alarm state, was active, send it to unlock.
Yeah.
Send the servo straight to unlock. So that would just be a quick, probably 4-line code.
Yeah.
If alarm statement equals true, send to servo to unlock. Good to go.
It really just be another sensor that you have to add on, just depending on what you want. You could add like a smoke sensor. Or
Yeah, that would be something going into a pin of the Arduino. If pin 13, what you're not using, is high or low, it's high, I'm up.
Thank you, William. Good question. Who? Who wants to ask question anymore? Everybody is satisfied with this presentation. And thanks to this presentation, I think you can create more interesting projects. And the level is going up. And the groups who will come later should prepare better than this project. This is my expectation. So thank you very much again. Question.